Welcome. Today, we're diving deep into a massive technological shift that's literally revolutionizing the financial and regulatory reporting world. We're talking about the major leap from clunky legacy XML structures to a modern API-driven way of handling data. So buckle up, because we're going to look exactly at how the XBRL Model API is completely redefining this space and solving those huge bottlenecks of the past once and for all.
So why are we talking about this right now? Well, March 2026. It's really not that far away. The Dutch central bank, De Nederlandsche Bank, has actually set this date as a strict, hard deadline. From that moment on, specific regulatory reports for the European Banking Authority absolutely must be submitted in the xBRL-CSV format. So yeah, there's a real sense of urgency across the industry to adapt to this new tech right now.
Here is our roadmap for this explainer. First, the problem with XBRL XML. Second, the solution through xBRL-CSV. Third, our main focus, the XBRL Model API. Fourth, the anatomy of OIM metadata. Fifth, the API for tables and columns. And finally, a quick look at the future of data processing.
All right, let's jump straight into part one, the problem with XBRL XML.
For years, classic XML was the absolute bedrock of digital financial reporting. And it served us well. But today, using it is kind of like trying to shove a whole library through a keyhole. XML is incredibly verbose, structurally super complex, and its data syntax is tightly coupled to its meaning. But modern demands? They require high velocity, massive data volumes, millions of repeating records, and just insanely high throughput. Basically, XML and our current data reality just don't mesh anymore.
So what does this actually look like in practice? Well, when you try to force millions of these granular, repeating transaction records into an XML format, you get massive physical data bloat. I mean, the files become gigantic. And to process these reports, systems have to build an entire in-memory document object model, or DOM, that literally eats up gigabytes of RAM, causes extreme computational bottlenecks, and drives network transmission costs through the roof. The whole system just groans under the weight. Which brings us to part two, the solution through xBRL-CSV. To fix this pressing issue and to even make xBRL-CSV possible in the first place, XBRL International pulled off a brilliant move. They created the Open Information Model, or OIM. Now, the OIM is a syntax-independent abstraction layer, and that is absolutely crucial. It completely decouples the underlying business semantics of a report from its technical representation, meaning it finally separates what the data means from how it's formatted. Thanks to this decoupling by the OIM, we can now represent the exact same semantic data without any loss across three interchangeable formats. We still have XBRL XML for legacy compatibility. Then there's XBRL JSON, which is perfect for web apps and developers. But the real game changer here, that's XBRL CSV. This is the highly compressed, high-throughput engine that the XBRL Model API relies on to process gigantic amounts of granular data with just unbelievable speed and efficiency. Let's move on to part three, the XBRL Model API. So, how do we actually control this powerful XBRL CSV engine in practice? This is where our centerpiece comes in, the XBRL Model API. Let's look under the hood. An instance managed by this API basically consists of three core data groups. First, the JSON meta information. Think of this as the master blueprint. Second, the actual CSV files, the raw data tables. And third, the taxonomy, which gives those raw data tables their structure and meaning via that JSON blueprint. The API is what orchestrates the perfect interplay between these three components. Let's walk through how this works in reality, say with a conversion tool like XBridge. The process the API runs follows very clear, logical steps. Step 1, it loads an existing XML instance to extract the raw facts. Step 2, it loads the taxonomy definitions. Step 3, and this is where it gets exciting, the API matches and validates those instance facts against the definitions. Step 4, it then generates those highly compressed XBRL CSV files and tables. And finally, Step 5, it packages everything neatly into a zip archive. It's just a perfectly streamlined API-driven workflow. Moving on to part 4, the anatomy of OIM metadata. We just mentioned the master blueprint. Since the OIM means we've said goodbye to that rigid, error-prone XML hierarchy, we need a new kind of glue to hold all this distributed data together. And that's exactly what the JSON metadata does. It acts as the master blueprint, defining the precise relationships between the tables, the individual CSV files, and the taxonomy references.
Without this JSON file, those CSVs would just be random columns of numbers that nobody could make sense of.
So what exactly is inside this blueprint? Well, at the report level, we have namespaces, which define prefixes and unique URLs. Then, taxonomy references link directly to the structural meaning. Now, table templates are especially important. They dictate exactly how a table needs to look. The table's object then connects a real CSV file to one of those templates via a URL. And finally, dimensions define report-wide core aspects like the reporting entity or the time period. Together, these objects organize all that decoupled data with absolute precision. To ground all of this in regulatory reality, the filing rules of the European Banking Authority, the EBA, rely heavily on these exact concepts. EBA frameworks demand strict templates, clearly defined entry points in the form of JSON or XML files, and specific reporting units. And the XBRL model API is tailor-made to map these strict requirements super efficiently using those JSON metadata files. So this isn't just theory, this is actually how it's done in the field.
Let's dive into part 5, the API for tables and columns.
Now we're zooming in one level deeper. The crucial point here is how table templates take control and how the XBRL model API enforces its strict rules. Basically, a template dictates the exact structure expected from any incoming CSV files. It has an identifier, it defines columns, objects that link to CSV columns via IDs, it sets decimals for the default accuracy of numeric facts, and it includes table-wide core dimensions like the concept or period. The API leaves literally zero room for ambiguity here.
And that strictness absolutely applies to the column headers in the CSV files themselves. These headers are the vital link between the raw data and our metadata. The API explicitly demands that strings follow strict OIM syntax restrictions. So, no whitespace whatsoever. They absolutely must not start with a number. A human-readable header like country of Inc. with spaces, totally invalid. It literally has to be something like country_of_incorporation. For the machine, unambiguous clarity is the top priority.
The API is just as ruthless when it comes to formatting the actual data cells. You can forget anything that looks pretty to the human eye. Thousand separators or currency symbols like a $sign? Absolutely invalid. They'll just be rejected right out of the gate. The API only accepts plain, naked numeric forms, just numbers and maybe a decimal point, nothing else. It's these incredibly clean data inputs that allow the API to process data at lightning speed without hitting those old XML bottlenecks. But wait, what happens if we don't have a value at all, or if we absolutely need a special character? Well, this is where the API shows how clever it really is. It uses a brilliant placeholder system to maintain that simple CSV structure without crashing. #none explicitly means no value. #empty is an empty string. #nil is a nil value. And if your actual cell value happens to start with a hash or a $sign, you can elegantly escape it with double characters, like ## or $. It's just a brilliant way to handle edge cases in simple CSVs without throwing the machine off track.
Finally, part 6, the future of data processing.
Let's take a look at the big picture here. The introduction of the XBRL model API and XBRL-CSV isn't just some minor software update, it's a full-blown technological metamorphosis. For financial technologists and compliance officers, the benefits are massive and tangible. We're talking about a truly syntax-independent digital transformation. You get maximum data throughput with minimum physical data bloat. You keep 100% of your semantic precision and regulatory reliability. And most importantly, the XBRL model API provides a rock-solid, future-ready foundation for cloud-native tools. Throughout this explainer, we've seen how the XBRL model API breaks the chains of legacy XML and opens the door to a completely new level of performance. The OIM has masterfully separated the what from the how. So if syntax is no longer the limiting factor, what exactly is the next limit in a fully decoupled data landscape? It's a pretty fascinating question to think about. Thanks so much for joining us for this explainer, and we'll see you next time.